Hey, in this video and subsequent videos I will be bringing you an entire calc-based physics lesson series. I will be going through each portion of physics and obviously starting with the basics. The first topic will be motion, and specifically this entire chapter, pretty much I guess you can say, will deal with motion in one dimension. Okay, one dimension, like a straight line. This lesson specifically will be on velocity and speed. At the beginning of each lesson I will be giving out some key terms. These terms are pretty much the core of the lesson. If you understand these terms and how they relate to each other, you understand the lesson. The key terms in this lesson will be displacement, distance, scalar quantities, vector quantities, average velocity, average speed, and position. The couple formulas you will see in this lesson is the one for displacement, where this triangle is really the symbol for delta, and it means a change. X is referring to position, change in position. X of f is final position. X sub I is initial position. This one here is your average velocity, and this X here is just representing the axis of travel, which most of the stuff we'll be doing is on the X axis, and it's the average, which would be the displacement, this, over some time interval. Average speed is going to be a distance over some time interval. But for now, don't worry about any of that. We're going to continue right along into the first part of the lesson. Okay, so first I have divided this into 6 sections. The ones on top are all vector quantities, in the middle saying vector quantity. A vector quantity specifies direction and magnitude. Specifically, the main thing to highlight here is direction. That's something that scalar quantities do not specify. So this here, average velocity and displacement, are going to be vector quantities, whereas distance and average speed will be scalar quantities, quantities that have a magnitude like a numerical value, but they don't specify a direction. So we're going to go more into that, and you'll understand in a second what I'm talking about. So I suppose we'll start off with displacement. To understand displacement, you need to understand position. But position is really simple. Say you have this line here, and we could call it a surface of some sort, maybe ice, and here's a block of ice on that ice, and let's say for whatever reason this is where your point of origin, where you're standing, and this block of ice is 5 meters away. Well, its position, the block of ice, the position of the block of ice is 5 meters away from the point of origin, or the reference point. So that's basically what position is. It helps to quantify distances and even directions. So displacement specifically is this change of x is referring to displacement, and it's the difference between the final position and the initial position of the object. So in a sense, if I threw a ball in the air, it goes and it went straight up, it would go straight up, straight down. Let's say it did it in 4 seconds. Okay? Well, the amount of displacement, that this is the initial position and the ball lands right here again, that displacement is 0. So do not relate displacement directly to distance, because in this case that would have been 0. So distance, in the sense, is going to be those total units traveled during the time interval. So the ball all the way up and all the way down, that entire unit, that'll be the total distance traveled. So that's one of the big differences between displacement and distance. For instance, if you have a basketball court, and here's the halfway mark. We'll call this the point of origin. And let's say basketball player right here starts the game right here, and we'll say that's 1 meter to the right, so it's positive. So he starts right here, 1 meter to the right, and he runs back and forth all game long, and he ends right here as well. His total displacement, the amount the object has moved over that interval, is 0. But the distance traveled is something completely different. It's the entire distance summed up of the entire game of him running back and forth. So that's the major difference between displacement and distance. Okay, so vector quantities. Let's see. So vector quantities, they establish both direction and magnitude. For instance, I could say -5 meters, and that would imply 5 meters to the left of some point of origin. Scalar quantities don't specify that. That would just be 5 meters. It traveled 5 meters. There's no direction to that. It's just 5 meters. So, average velocity is a vector quantity, and it references that axis upon which you're moving along. This change in x is your displacement, and this is your change in time. So, for instance, if you have that same basketball player that we talked about down here, his total displacement, because he landed at the same spot at the end of the game, is going to be 0. Time interval could be whatever, it doesn't matter. The velocity is still going to be 0, the average velocity. So there needs to be something to help define how fast was he moving during that distance he covered. Hence, average speed. Average speed would sum up all the different intervals of all the different units he traveled, and divide it by the amount of time that you're interested in, your time interval. Alright, so moving along. Okay, give a little bit more of an understanding of displacement, distance, average velocity, and average speed. Let's see, put that over there. We'll start off with displacement once again. We'll create, this is a block of ice, and this is the initial xi, is the initial time interval. And displacement, remember, is change in x. Displacement is equal to the final position minus the initial position. So here's our initial position, and let's say the average time, or each time interval is 2 seconds between each block. So we'll just say change in time is 2 seconds per block of, I don't know, time interval. So let's say the second interval, we close our eyes and open them, boom, the block of ice is here. Third time, the block of ice is here. And the fourth time, the block of ice goes back to the source of the origin, and that'll be number 4. So the displacement is going to be, and this, mind you, is your final position. And your displacement is going to be equal to your final position, which is 0, minus your initial position, which is at 10, and you get -10, and -10 will be the total displacement. So basically, during whatever time interval, the entire 1 through 2 through 3 through 4, the block of ice overall shifted left 10 units. That is what the negative means in displacement. Also kind of a little hint that this is a vector quantity. So average velocity with respect, and remember this is the x-axis, so with respect to positions on the x-axis, average is going to be your change in position over your change in time. So if each interval, I shouldn't have put this as delta t up here, I should have put it as something else. Each interval is 2 seconds. there's 4 intervals, so it's a total of 8 seconds. So your change in t there, your total change in t is 8 seconds. And your total displacement we found to be -10, and we'll just call these meters. So all those are meters, so we'll put -10 meters a second. So it's the average velocity of the ice cube is -5/4 meters a second, or basically 1.25 meters a second. So the distance between that and the distance is the sum of each one of these units. It's going to be, starts at 10, and it moves from 1 to 2, it moves to 30, so that's 20 meters. From 2 to 3, it moves from 30 to 0, so 30 to -30, which is 60 meters. And then from 3 to 4, it moves from -30 back to 0, or 30 meters. So 60, 90, 110, 110 meters. That is the total distance traveled. So the average speed, without reference to position or x-axis, is simply going to be the distance traveled over the time interval. So that will be 110 meters over 8 seconds. And you can do the math, but you notice the difference between average velocity and average speed in this scenario. Okay, so I basically, to sum everything up, displacement and average velocity are vector quantities, meaning they have both a direction and a magnitude. The formula for displacement is the final position minus the initial position. The average velocity is concerned with displacement, whereas average speed is concerned with total distance traveled. For instance, if you had a race, if you had, like, let's say, if you had someone running around a track, and this is the track, but we just extend it. Alright, whatever. They're running around this track. And this is the point of origin. And they run all the way around, and then they get right back here. There needs to be a way to tell how fast he was moving around this track. And your average velocity won't do that. That's why you need average speed. So as we go into future lessons, we'll learn more about what the difference is between the two, but know for now that there is a major difference between the two quantities, average velocity and average speed, in displacement and distance. So thanks for watching, and I will be back for another video soon.